In the last video, we looked at what the quadrant of an angle would tell you about whether the sine, cosine, tangent was positive or negative. And we summarized that with this little mnemonic device, ASTC. So go back and look at that video if you don't remember what that means. Now we want to talk about, is the angle red, blue, or purple, and what that tells us. So let's focus in on the red angles. These are all the angles that are 30 degrees away from the x-axis, either above or below. And they all have the same numbers in their terminal points. We used this fact when we were filling out the unit circle, root 3 over 2, comma 1/2. And then the blue angles are the ones that are 45 degrees away from the x-axis. And then the purple angles were the ones that were 60 degrees away from the x-axis. All right, and so I'm drawing these connected to the x-axis because this is what we're going to define as an angle's reference angle, how far away it is from the x-axis. All right, so for the angles that we have drawn on the unit circle, they're all, the red, blue, and purple ones anyway, they're all either 30 degrees, 45 degrees, or 60 degrees away from that x-axis. And that's what we're going to call the reference angle. So here's our official definition of a reference angle. The reference angle of angle theta, we denote this with a theta prime for the reference angle. This is the acute angle. So remember, acute means that you're between 0 degrees and 90 degrees. Okay, so theta prime is always an acute angle made by the terminal side of theta and the x-axis. So it's going to be in the angle that's your quickest trip to the x-axis, either up or down. So let's see if we can find the reference angle for these 4 angles. And none of these angles are angles that are actually labeled on our unit circle, but all angles have a reference angle. So let's draw this first angle, 130 degrees. It's obviously more than 90, less than 180, so I'm somewhere here in the second quadrant. All right, and remember that the reference angle is the acute angle that the terminal side makes with the x-axis. So that's got to be this angle right here. All right, and I'm specifically not going to put an arrow on that because for reference angles, it doesn't matter whether you rotate counterclockwise or clockwise to get there. We just want the degree measurement between 0 degrees and 90. Okay, so to get from 130 degrees to 180 degrees, I've got to go 50 degrees. And that's my reference angle for 130. Second angle is 9 pi over 8, and you're probably going to be tempted to convert this to degrees to figure out the reference angle, which you are welcome to do. But in the end, because I gave you this angle in radians, you need to state the reference angle in radians as well. So you can do that. I'm going to stick in radians and show you how to think about this without having to convert through degrees. Okay, so I'm going to draw the angle 9 pi over 8. So how in the world do you draw 9 pi over 8 without knowing how many degrees it is? Think about the angles that you do know in radians. So I for sure know if I go over this far, I'm going to get to pi. Just rewrite pi as an angle over 8. Well, I'd have to have 8 pi over 8 so that they would cancel out and leave me with pi. So if I go this far, I would make it 8 pi over 8. I need 9 pi over 8. And probably you should have some intuition. This is going to land you in the third quadrant. But just in case, you could come down here at 3 pi over 2. And write that, let's multiply that one by 4 over 4. That would give me 12 pi over 8. Okay, so that would be too many pi's over 8, right? I just need 9 of them. I have 8 of them. If I go to pi, I don't want to go all the way past 12. So I'm just going to go a little bit past 8 pi over 8. And this would be my angle 9 pi over 8. All right, so what's my quickest trip to the x-axis? That's going to be that little guy right there. And we know from what we just figured out, I went from 8 pi over 8 to 9 pi over 8. I only went that one little slice, pi over 8. And that's my reference angle. Third angle, negative 75 degrees. Let's draw this one in standard position. So negative means I want to go clockwise. And I don't want to make it all the way to negative 90, so I'm right here, negative 75 degrees. All right, so your reference angle is always your smallest angle that connects to the x-axis, always the x-axis, never the y-axis for reference angles. So we're going to say this angle And that angle is going to be 75 degrees. So remember that reference angles are always acute, which means they're between 0 and positive 90 degrees. So you always represent them as a positive angle between 0 and 90 degrees. All right. So then our last angle is 7 pi over 3. So let's use the same trick so we can avoid converting to degrees. Again, you're welcome to convert to degrees, but once you find that reference angle, you got to convert right back. Okay, so 7 pi over 3. We're going to think about our big stops on the unit circle in terms of pi over 3. So when I'm out here at pi, I want to think about that as 3 pi over 3. I definitely need to do more than that. If I make it all the way a full circle, I've got 2 pi here. And you can think of that as 6 pi over 3. I need one more pi over 3. A full revolution gets me 6 pi over 3. I want one more pi over 3. So I'm going to end up right at regular old pi over 3 for my terminal side. And by the time you've done all this thinking about where the angle is, you've already accidentally figured out the reference angle, right? The angle between my terminal side and the x-axis is that pi over 3 that I had to go extra past 6 pi over 3. So pi over 3 is our reference angle. So how are reference angles going to help us? Well, if you have an angle that's terminal side lands on one of those 30, 45, or 60 degree spokes around the unit circle, even if it's a negative angle or an angle that's bigger than 360 degrees, the reference angle is going to tell you whether it's a red, blue, or purple angle, whether it's a 30, 45, or 60 degree reference angle. Once you know that, you know the coordinates of the terminal point. You know what the numbers are, and then you can use the quadrant information to figure out if your sine, cosine, or tangent should be a positive number or a negative number. And we'll do this together when we get together in class.